Solution of a quadratic equation can be found by factorization method of splitting the middle term. Factorization can be simple for some quadratic equations, but for some other equations, factorization can be complicated or tedious. So let's see a better method to solve such equations. The product of Sally's age in years 3 years ago and her age 5 years from now is 1 more than twice of her present age. What is her present age? Let Sally's present age be x years. According to the information, x minus 3 into x plus 5 equals 2x plus 1. Simplifying this, we get x square minus 16 equal to 0, which is a quadratic equation. It can be written as x square equal to 16. Then, by taking square root, we get the solution as 4 and minus 4. Since the age cannot be a negative number, we take x equal to 4. So, Sally's present age is 4 years. So, this quadratic equation is in such a way that we just need to take square root to solve. Now, let's see another type of quadratic equation which can be solved in the same manner. The quadratic equation x plus 2 whole square minus 16 equal to 0 can also be solved by taking the square root. We get the solution as 2 and minus 6. Now, have you given a thought of why we are able to solve these two equations easily? It is because the term containing x is completely inside a square and roots were easily found by taking the square roots. Now, check the quadratic equation x square plus 4x minus 12 equal to 0. In this equation, the term containing x is not inside a complete square. So, let's solve this by factorization. We get the solution as 2 and minus 6. But have you noticed that x plus 2 whole square minus 16 equal to 0 and x square plus 4x minus 12 equal to 0 are the same quadratic equation in different forms? We can confirm that by expanding x plus 2 whole square minus 16 equal to 0, and we get the equation x square plus 4x minus 12 equal to 0. So, for equations of the form ax square plus bx plus c equal to 0, if we make it to the form x plus p whole square minus q square equal to 0, we can solve easily. To understand the concept of converting an equation to this form, let's consider the first two terms of the equation x square plus 4x minus 12 equal to 0, that is x square plus 4x. We are going to convert this to x plus 2 whole square minus 4. Now let's diagrammatically describe x square plus 4x by joining a square of side x and a rectangle of sides 4 and x. Now divide this 4x into two halves, that is x square plus 4x equals x square plus 4x by 2 plus 4x by 2, which is x square plus 2x plus 2x. Considering the square and the first rectangle together, we can write it as x plus 2 into x plus 2x. Now this remaining 2x can be shifted to the adjacent side of x square and can be written as x plus 2 into x plus 2x plus 2 square minus 2 square. Grouping the newly formed square alone, we can write it as x plus 2 whole square minus 2 square, which is x plus 2 whole square minus 4. So, x square plus 4x minus 12 equals x plus 2 whole square minus 4 minus 12, which is x plus 2 whole square minus 16. Since x square plus 4x minus 12 equal to 0 can be written as x plus 2 whole square minus 16 equal to 0, by the process of completing the square, this method is known as the method of completing square. In brief, we can write x square plus 4x as x plus 4 by 2 whole square minus 4 by 2 whole square, which is x plus 2 whole square minus 4. So x square plus 4x minus 12 equal to 0 can be written as x plus 4 by 2 whole square minus 4 minus 12 equal to 0, which is x plus 2 whole square minus 16 equal to 0. Let's see another example. 3x square minus 5x plus 2 equal to 0. The first step is multiplying throughout by 3 to make the coefficient of x square a perfect square. Then in the LHS, 9x square minus 15x plus 6, considering the first two terms and comparing it with the algebraic equation a minus b whole square equals a square minus 2ab plus b square, we can write 3x whole square minus 2 into 3x into 5 by 2 and then add and subtract the b square term in that algebraic expansion, that is 5 by 2, so that the first three terms become the expansion of a minus b whole square. Simplifying the rest of the terms, we get the quadratic equation as 3x minus 5 by 2 whole square minus 1 by 4 equal to 0. Now it's a complete square equation. Solving this, we get x equal to 1 or x equal to 2 by 3. Therefore, the roots of the given equation are 1 and 2 by 3. An alternate method to get the complete square equation is to make the coefficient of x square as 1 and then following the same steps, we get the quadratic equation as x minus 5 by 6 whole square minus 1 by 6 whole square equal to 0. Solving this, we will get the same solution. So we can conclude that we can solve a quadratic equation by completing the square and then solving it just by taking the square root.